Yeah. Okay. So here's a bell curve, right? We're told in the problem that the width of the jaws of great white sharks is normally distributed, right? Which tells us it's unimodal and symmetric. And it has a mean of 15.7 and a standard deviation of 2.8. So most of the time, when you're dealing with a normal distribution, if a problem tells you this data is normally distributed, the first thing you do is draw a bell curve. Right? You draw yourself something that looks about like that. Okay, you label the very middle of the curve as the mean. That's always the mean. In this case, 15.7. Right? And then you're going to mark off increments of the standard deviation. So add 2.8 to 15.7, you get 18.5. Add it again, 21.3. Add it again, 24.1. Right? Now, a lot of people, when they sketch their normal curves, they're going to do something like that or something that really doesn't look anything like a bell curve at all. But if you are trying to make a bell curve that looks pretty good, notice the shape of this graph, right? It's opening down in the middle, right? This is called concave down. But over here, it's concave up, right? It's changed its opening. Like here, it's concave up, right? Now, there is a point in between here and here where this thing changes direction. And it's exactly at 1 standard deviation to the right, where it's no longer opening down, it's opening up. That's called a point of inflection. The point of inflection is always 1 standard deviation to the right, 1 standard deviation to the left. And I believe I read in another book that the height from here to here is 60% of here to here. I never get that accurate when I'm drawing these things. But okay. Now, if I did a z-score on this 15.7, what would the z-score be? 0. Why? Because it is the mean, right? If you subtract 15.7 minus the mean, you're subtracting 15.7 minus 15.7, which would make this 0, right? And then remember, z-scores are your number of standard deviations from the mean. So what would be the z-score at 18.5? 1 and 2 and 3 and -1 and -2 and -3. So you can see normal curves that are done in different ways, right? If you see it with the mean and the standard deviation, that's a normal curve, right? If you see it with the middle, the mean is 0 and the standard deviations are marked off, 1, 2, 3, that's called the standard normal curve, right? Standard normal curve. The shape is the same. It does not change it at all, whether you've got it labeled like that or like that. The shape is exactly the same. The area under the curve is exactly the same. Okay, I think that's good.